Hello everyone, welcome to the video explanation for Brian Passwater's Topic 25 Notes Example 2. Example 2 says for the t-values 0 to 30 minutes, including 0 and 30 minutes, the number of fans inside of a large sports stadium can be modeled by the exponential function f of t equals ab to the t, where f represents the number of fans inside the stadium t minutes after the doors open. There are 47 people in the stadium 2 minutes after the doors open, and there are 2,602 fans inside the stadium 20 minutes after the doors open. Use the given data to write two equations that can be used to find the values for the constants a and b in the expression for f of t. All right, so this is a very important example for us because this is going to be in one of our FRQ models. There's going to be a problem where we have to write equations based on information that we are given. And the equations themselves will be the FRQ points, not using the model, the regression model, to find these numbers. So what we do is, well, actually we probably still will have to do a regression, but this will be a very important thing here. Okay, so we're told exactly what model to use. We're told that f of t is a times b to the t. And then we are told two sets of information. There are 47 people in the stadium 2 minutes after the doors open, and there are 2,602 fans 20 minutes after the doors open. Those are points. Those are two different ordered pairs that would be used to model the situation. We have 2, 47, t, f of t. We have 20, 2,602. Now, these are values for t and f of t. This is t and this is f of t. This is t and this is f of t. Okay, so in both cases, we can take these points and plug them into the function for t and f of t, which generates two equations. The first equation uses the first point. So we would take that point, the green point, and plug it in for t and f of t, which means we would have 47 equals a times b to the second power. And then 2, our second equation, would be from the pink information. Same idea. 2,602 equals a times b to the 20th power. Those two equations have two unknowns, a and b, which means these would be the two equations that we would need to write to solve for the values of a and b. Then it does say, please use your TI-84 to create an exponential regression model. And the notes lay out very clearly how to do that, but I'm going to demonstrate for you as well. So what we're going to do is, on our calculator, we are going to edit our stat lists. So we're going to go into our calculator, we're going to hit stat and edit, hit enter. And into those lists, we're going to type our 2 points. So we have 2 and 20 for our inputs, and we have 47 and 2,602 for our outputs. So you can see your 2 coordinate points are listed in L1 and L2. Then we're going to run an exponential regression on those. So we hit stat again, go arrow over to calculate, and we are going to choose the exponential regression, which is option 0 in the list. We want L1 and L2 to be our x and y's, because that's the way we listed them, x in L1, y in L2. And we want to make sure, again, like always, that the frequency list is blank and that we store the equation as y1. So we hit alpha, trace, and choose y1 from the menu. Then we hit calculate. Right there you can see those numbers that we expect to see for A and B. So our model would be, go back over to the other and write this out here. Remember that we would not round these numbers for calculations in the calculator, but when we're giving the equation model, we would round these numbers off to 3 decimal places. So our model which we know is going to match this model right there, would be f of t equals our a value from the calculator, which is 30.089, times our b value from the calculator, which would round to 1.250 to the t power. So there is our regression model from the TI-84, which we could use to answer additional questions if there were additional parts to run.